Today we're going to do some linear programming, and so we're going to do first the word problem, and then we're going to talk about some other situations that may happen when doing these graphs. So we got the manager of a gift store is printing brochures and flyers to advertise sale items. Each brochure costs 8 cents and each flyer costs 4 cents to print. A brochure uses 3-pager and a flyer requires 2. The manager does not want to use more than 600 pages. She needs at least 50 brochures and 150 flyers. How many of each should be printed to minimize the cost? There's X and there's Y. So let's come up with some equations. Alright, so they don't want to have more than 600 pages, so we need to figure this out. So we're going to underline this part over here. So a brochure takes 3 and a flyer requires 2, and we can't use more than 600 pages. We need at least 50 brochures, so X has to be greater than or equal to 50. Y has to be greater than or equal to 150. And for all these problems where we're talking about real life situations, generally speaking, we're in quadrant 1 because we can't make a negative amount of flyers or a negative amount of brochures, so we're going to graph this in the first quadrant. Okay, so each of my tick marks I'm going to make 50. I'll make that 50 as well. And so X is greater than or equal to 50. I'll start out with the easy ones. There's a vertical line like this, and I'm going to shade to the right. And Y is greater than or equal to 150 is, there's 150 going across, and I'm above that line, so we have sort of above and to the right of these two lines. For the last one, I'm going to subtract 3x, and then I'm going to drop this to the bottom so I have a little bit of room to write. Negative 3x plus 600 divided by 2, and y is less than or equal to negative 3 halves x plus 300. Well, up here is 300, and I go down 3 over 2. Now it just so happens that if I go down 3 over 2 or go down 3 times 50 over 2 times 50, the slope is the same. So we got, that should have been a straight line, but we'll try it again. That was a little bit better. And we are less than this line, so I'm going to shade so we have this little triangle in here. So in order to figure out these points, I need to figure out where these all intersect. Well, this first point down here happens at 50, 150. This point over here turns out to be, that point turned out to be 100, 150. And this point over here turned out to be 50, 225. And I found that by plugging x equals 50 in there because I knew x equals 50 into that equation down there. So on the next page, I'm going to have these points written down. 50, 150, 50, 225, and 100, 50. I meant 100, 150. Alright, so here are the points. And let's go back to read the problem. And we're talking about the cost that we're trying to minimize, which says 8 cents for each flyer or each brochure and 4 cents for each flyer. So we're going to do 8x plus 4y and leave that in cents as my function for the cost. So 8 times 50 plus 4 times 150. 8 times 100 plus 4 times 150. And 8 times 50 plus 4 times 225 equals, this one is 1,000 cents, the second one is 1,400 cents, the last one is 1,300 cents. So because they were asking for what is the least amount, my answer is 50 brochures and 50 flyers, or 150 flyers, because that was the cheapest. A couple of things that may happen along the way when we're graphing. If I were to graph these two lines, and if you notice that they are parallel, and I wish I could draw better on this, but we get the picture here. And if I'm greater than 2x plus 3, that's the stuff over here. And if I graphed it under the 2x minus 1, that's going to be the stuff that's over here. So where did the black and the red intersect? Nowhere. So in this case, there is no feasible region. And the other thing that may happen when we graph is something that looks along the lines of this problem. So if x is greater than or equal to 3, there's 3, and we're over to the right. Y is greater than or equal to 5, I'll do in red, where we have this. And in green, we have x is less than or equal to 6, which I have this way. And so, looking at this, there is no bounded region. And that'll be it for this lesson. A little bit longer, but, word problems.